everyone, and welcome to this video. This is a Math-O-Witty 1 video from Chapter 3, Section 1. In this video, you will learn how to evaluate formulas and then to solve formulas, including real-world formulas, for a specified variable. Let's get started. In order to evaluate a formula, all you have to do is substitute the given values in place of the variables in the equation. And then we can use algebra, if needed, to isolate the variable that's remaining. So let's do an example right here. It says the formula for the volume V of a rectangular solid is V equals LWH, where L is the length, W is the width, and H is the height. And then they're asking us to find the volume if L is equal to 10, W equals 6, and H is equal to 12. So down here, usually what I do is I recopy the equation. V is equal to LWH. And then we know that the length is equal to 10. So in place of L, I'm going to write 10. In place of W, I'm going to write 6. And in place of the height, I'm going to write 12. Okay, so far so good. So now all I have to do is to use calculator or whatever I want to actually evaluate this. So we have 60 times 12. And then the volume ends up being 720. Okay, so again, all we did was plug in the values for the length, the width, and the height, and evaluate for the volume. Let's do another example. So now we have the formula for the area of a triangle, and they tell us that the formula for the area of a triangle is 1/2 times the base times the height. And then they give us this information. They say, okay, well, the base is 10 units and the height is 6 units. So then we need to plug those in order to find the area of the triangle. So again, the base is 10. The height is 6. Plug those in. So we have area is equal to 1/2 times 10 times 6. And that's going to end up being 30 units. Okay, let's do another example. It says the formula used in a constant velocity or constant speed problem is distance equals rate times time. So let's write that down here. Distance equals rate times time. Okay, then we're given the fact that the distance is 120 units and the time is 2 units. Again, we don't know what those units are. So let's plug those values in. So we have the distance is 120, so I'm going to put 120 over here in place of the distance. And then we don't know R, right? We're trying to find R. So I'm going to leave it as a variable. And then I'm going to put in T is equal to 2. So take a minute and look at this problem. See if you can figure out what's different. If you notice, what's different here is that I'm not done. Usually after I substituted all these values into the variables, I'd be finished and I could move on. This time, I still haven't isolated my variable yet. There's a 2 sitting right next to the R, and I gotta get rid of that 2. So I always ask myself, well, how is that number attached to the variable? Well, 2R implies multiplication. So to undo multiplication, we need to divide both sides by 2. And we find that our rate is equal to 60 units. Again, the units are not given to us. Okay, let's do a few more examples. This one says a formula from chemistry is equal to the density is equal to the mass divided by the volume of a substance. Okay, and then they want us to find the mass if the density is equal to 2 and the volume is equal to 64. So let's go ahead and do that. Again, the first thing I always do is just copy over the equation. Density is equal to mass times volume. Mass divided by volume, rather. Okay, and then I'm going to plug in 2 for the density. I'm going to plug in 64 for the volume. Okay, and again, unlike the first few problems we did, we're not done, right? We haven't isolated our variable yet. So I always ask myself, okay, well, here's M. How is that 64 attached to the M? Well, hopefully you can see that M is being divided by 64. How do we undo division? Well, we undo division using the inverse of division, which is multiplication. So the only way to get rid of that divide by 64 is to multiply both sides by 64. So then over here, these 64s cancel out. I believe over here, we end up with 128. Okay, so the mass of whatever this is 128. Again, we left off the units just to make this really simple and straightforward. Okay, all right, we have time to do a few more problems, so let's do a few more. It says the formula for the perimeter of a rectangle is P is equal to 2 times the length plus 2 times the width. Okay, but this time we're not asked to find the perimeter, right? We're asked to find the width, given that the perimeter is 62 and the length is 20. So let's plug those numbers in and see what happens. So again, the perimeter is 62, the length is 20, and then we'll go back and sort of fill in the equation around these values here. Okay, so we have 62 is equal to 2 times 20, that's 40, plus 2w. So again, we still have some work to do. We have to isolate our variable. We have to solve for w. Okay, so remember, you always work farthest away from your variable and you work closer and closer. So the first thing I'm going to need to do is to subtract 40 from both sides. And then you get 22 is equal to 2w. Again, the way to get rid of that 2 is to undo multiplication. We undo multiplication by dividing, and we find that the width of this rectangle is 11 units. Okay, let's do one more example. Okay, so we're going to do number 6 here. It says to graph a line. Let's see, let's do it on this page. To graph a line, you need to be able to evaluate a formula that represents the equation of the line. For the line 4x plus 3y equals 32, find y if x equals 2. So let's write our equation down here. We have 4x plus 3y is equal to 32. Okay, and again, we're given the fact that x is equal to 2. So wherever I see x in this equation, I'm not going to write x anymore. I'm only going to write 2. And then I'll go back and sort of fill in the rest of the equation around that 2. Okay, so 4 times 2 is 8. 8 plus 3y is 32. And again, now we have this 2-step equation that we have to solve. So we have 3y is equal to 23. Okay, so then we divide both sides by 3. And remember, in this class, the preferred way of expressing rational numbers like this is to leave them as an improper fraction. Okay, so that includes the first part of 3.1, where we are evaluating equations and solving for a given variable.